Hey everyone. Sorry I'm not there today. I hope that you all actually tried to do the bell work on your own before watching this video. Um, but it's not really graded, it's just for your own benefit. So tomorrow's your bell work quiz. You should be getting better at these type of problems. Um, let's just go ahead and start. Column 1 says a letter from the word below is chosen at random. Find the probability. So we're trying to find a letter with at least one line of symmetry. Okay, so I don't know if you guys have heard of a line of symmetry before. I'll draw a picture of a square. Okay, and so a line of symmetry means I could fold it directly in half, right? And both sides would be exactly the same, right? And for with a square, this one's actually has more than one side of symmetry because I can fold it in half this way and have two rectangles that are the same. Or I could fold it in half this way and have two rectangles that are the same. Or I could fold it in half diagonally and have two triangles that are the same. And then again here, right? So I know it's not a perfect drawing, but I have 4 lines of symmetry of how I could cut my square, right? So if I'm looking at the letter H, a line of symmetry, I could put it right down the middle, right? It'd be like if I was just folding this H in half, right? Both sides of the H would be the same. So this has one line of symmetry here, right? One line of symmetry here and one here, right? If I were to draw a dotted line through the horizontal line on my H, both sides would be the same. So this has 2 lines of symmetry. So thinking of a line of symmetry, which of these letters could we cut in half, right? And have both sides be the same? How about my S? If I were to cut it in half, would both of my sides look the same? So I have this and this on one side and this on the other. So no, this one does not have a line of symmetry. But a Y does, an N does not, T, H. What about my E? If I cut it vertically, right, there would be no symmetry there. But what about horizontally? Could I cut this horizontally and have it be the same on both sides? Yeah, there's a line of symmetry in my E and I. Okay, so how many did I mark? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 14ths. So there's 9 letters with a line of symmetry out of the 14 letters. All right, so number 2, I have my rise over my run. So I would ask you guys, how far did I rise? How many squares did I rise? 7. And how far did I run? 2. So my slope is 7/2. And then my y-intercept, my b, is where my function crosses the y-axis. So down here, right, if this is my origin, I have 1, 2, 3 spots below the origin. That's -3. So this is y equals 7/2 x minus 3. All right, column 3 says, Caitlin works at a part-time job at the bookstore, which pays $55 a week. She has already saved $120 towards the purchase of her new $450 iPad. How many weeks must she work in order to have more than the amount of money to buy the iPad? Okay, so we know she wants more than or equal to $450. Well, actually, I think this one is not greater than or equal to, because it says how many weeks must she work in order to have more than, right? More than is just greater than. So this amount that she wants is more than $450. So she has $120 saved, and she makes 55 per week. Okay, so our variable's X, and I'm going to subtract 120 on both sides to get 55x. 55x, sorry guys, is greater than 330. Okay, so to get x by itself, I just divide by 55, and that will give me the number of weeks she needs to work. So that is x is greater than 330 divided by 55 is 6. X is greater than 6. So that is my answer. She has to work 6 weeks or at least 6 weeks, right? She has to work more than 6 weeks to have more than enough for the iPad. Okay, and then your favorite question, the simplifying radicals. We have 4 times the square root of 384, and I'm just going to try stuff here, guys. So I'm going to drag this over. Now 384 ends in a 4, so I'm thinking it might be a factor of 4 or 16 or maybe even 36. So I'm going to just try things. 384 divided by, let's try 36. Nope. 384 divided by 16. Okay, so that was a good one. But I'm still not broken down into my primes. So let's write this as 16 times 24. Okay, and so 24 is 4 times 6, right? So instead of writing 24, I'm going to write 4 times 6 because I want to get out as many perfect squares as I can. Okay, so I have a perfect square here. This comes out as a 4, right? And I have a perfect square here. This comes out as a 2. So I'm actually doing 4 times 4 times 2, and then the square root of 6 is my remainder. So 4 times 4 is 16, and 16 times 2 is 32. So I have 32, and then the square root of 6 is my remainder. Okay, so hopefully you're getting better at this. And tomorrow's your Bellwork quiz, so you might want to take a look at it beforehand. And we actually did the Bellwork quiz problem for this on, I believe, Tuesday. So maybe review that before taking your quiz. All right, guys, have a good day. Bye.